Welcome to the Brooksville chapter of Reasons to Believe. My name is Gary Hamer. I am the chapter leader here in Brooksville. And tonight it is my distinct honor to introduce to you Dr. Thomas Woodward, who is going to speak to us about shocks in the genome. And I hope this is going to, for those of you that were here last month, this is going to play very nicely into what we talked about last time. And the doctor is going to expand on things and show you some stuff that will absolutely amaze you. So please give Dr. Tom Woodward a big hand as we welcome him up here.
Can you hear me now? Is it on? I see a green light. Okay, very good. Excellent. Well, I've heard so much about this chapter. I love Reasons to Believe. We've had Hugh Ross at Trinity College, where I teach, several times to speak. You know, I think the campus kind of hovered off the ground 5 inches, you know, on those 2 occasions. And we are just thrilled. My colleague, Don Spence, you can say thank you to Don. Let's all say thank you, Don. Yeah, he was my helper in getting things together, getting up here sort of on time. So thank you for your patience. We had a little glitch with electronics, and it's all solved, and we're pressing ahead. So my background in this whole area of DNA, and I have my DNA tie ready to put on, but it's a little warm. And the DNA tie, beside it being warm outside, this is a worn, W-O-R-N tie. It's suffered a little bit from what you call entropy. The creep of entropy, you know, molecular disorder is always on the increase. Just look at your own rooms at home. I won't go there. I know our rooms are showing high entropy. But the reason I bring this tie, number one, I picked it up in Countryside Mall there in Clearwater. I just like, they had a little place in the middle of the aisle, you know, in the kind of the mall area, the open area, and I thought, whoa, that's a really cool tie. But one of the reasons that we try to bring DNA down to the level of an ordinary, you know, high school graduate or somebody who may have had some college, because DNA really is powerful evidence for design. It's incredibly compelling, and I think that if you've ever read any of the wonderful books by Stephen Meyer, he's one of my heroes. Hope you've enjoyed his either videos, maybe even a book or two. He has a book called Signature in the Cell. It is a powerful book. I've read at least 95% of it. I can't vouch for every page, but it's a great book. And Signature in the Cell, to me, hits the nail on the head. Because he's saying we see intelligence, and not just ordinary, really advanced. What Fred Hoyle, the famous, knighted by Queen of England, Sir Fred Hoyle said, a super intellect appears to have intruded. I think he used the phrase, a super intellect has monkeyed with physics and chemistry. And he was dealing with fine tuning. I would say, just go one more step up from that, the super intellect, the creator, has shown his macro intellect on the hard drive of the genome. And I brought with me a hard drive. You know, it has the little twirly thing. I don't think they use the twirly things necessarily anymore. They moved beyond that, right? That's last generation, or maybe 2 generations ago. But when my computer repairman gave me, and this is 1.0 TB, I think it's terabyte, so it's got some content. And I'm not saying every cell in your body is a terabyte, but we're going to talk about how the DNA in your cell is equivalent to 6.2, because you've got your diploid, half from mom, half from dad, your DNA. It's 6.2 billion letter pairs, which is rungs on the ladder of DNA. That's a lot of information packed in the hard drive, the genome of every cell. I'd say that is a statement that the skeptical world can really consider. Now, I'm a skeptic by background. My oldest brother, Bill, I had four boys. I was the youngest. Grew up in Alton, Illinois. Anybody heard of Alton, Illinois? Across the river from St. Louis. Okay, yeah. So I was out. We moved there in '56. I was 6 years old, And then, and I became like, baptized, well, I was baptized at age 1, but I became a member of the Presbyterian Church. We moved back to Central Ohio, and then I became a member of the youth group and went through all the, jumped through all the hoops. And by the time I was a senior in high school, I had dropped the faith quietly, didn't tell my parents, and I was an agnostic. Anybody else identify with that? And in my case, my 3 older brothers were setting the standard because they had all gone the same route as my dad to Princeton University. And so I thought, well, I'll apply to Yale, and I was fortunate to get in both, and I made my dad eternally happy by turning down Yale and going to Princeton, okay? But God had a plan. What was God's crazy plan? Because he knew, as a hardened, well, a convinced Darwinist and a, let's say, fledgling atheist, I needed to have some people wake me up. And so that's where I met some Christians, and I can tell you my story in more detail, but it was the Darwin issue that I was trying to correct them on. And then they wound up sharing information, a DNA, if you will, of God's love from Isaiah 53. Okay, many of you are familiar with that chapter. That powerful witness of Christ dying for me and rising again, and the last 3 verses and other verses, of course, were brought in. I fought it for 6 months, and then finally in May of '69, at the end of my freshman year, I received Christ. And then as I was going back to the campus from the apartment where I was, my first baby, I'm in the infancy of being in the delivery room. Okay, dear Lord, I pray I don't have to be involved with this Princeton Evangelical Fellowship group because they're all a bunch of creationists, Lord, and you know I'm a Darwinist. I can imagine God saying, permission denied. And that whole issue kind of faded to the background, and within, I would say, about 2 or 3 days, the fog had lifted, and I went to my first fellowship group, and I felt that fantastic connection of God working through the loving community of his people. And I still was thinking, well, I'm still a Darwinist, but I can hang out with these people. They're nice. They're my brothers. And then in the middle of that summer, I encountered fossil evidence from a friend at our local church that was really conflicting with everything I'd been told. I said, what? And he told a little bit more, and I said, what? Cambrian explosion, other things like that. And so within about 15 minutes, I embraced the idea of God really was behind this, and not just a kind of a blind, random, slow process. And so that's a bit of my story. And as I was going through my studies, I was a Latin American studies and history major. Then I went to, after serving in the Air Force, I went to Dallas Seminary, loved my experience there. Was able to meet J.P. Moreland. Some of you have heard of him, a great, fantastic author. And he was in my class at Dallas Seminary, Darrell Bach, some wonderful, wonderful friends. And so I feel like I'm just the midget who's been able to walk down on the shoulders of giants. And so I thank you for allowing me to share what I have learned about DNA over the next, about 30 minutes. And Don, if you would just come in at the end, if I can just have my friend Don give a little testimony about a key scientist at Rice University and how, is that okay? Okay, so let's proceed. And the title again, I thought, and Gary and I were discussing this, and he said, that sounds good, shocks from the genome, shocks. Why do I use the word shocks? I think it's shocking, genuinely, to see what is coming out of genetics and just molecular biology in general. By the way, C.S. Lewis loved that word, shock, and he almost used it for the first part of his radio talks, which became Mere Christianity. Did you know that? His proposal to the BBC, as he was accepting, the letter actually is in his collection, he said, let's call it the art of being shocked. In other words, he was going to present the case for God from the moral right and wrong, which we know is there, is true, it's real. It's not just something we made up. And so I actually have used for some of my titles, the art of being shocked. Well, we're just going to talk about one source of that shock, and that is from the genome discoveries in and around the genome that stunned science. And this is a book I was able to work on. It's out of print, but you can still get the Kindle download if you're interested through Amazon or whatever. But Dr. Gills, the eye surgeon, asked me, would I be willing to write this book with him? And we just had far too much fun researching the area of the epigenome. And that's the world the mysterious epigenome, is like the coordinating cluster of other codes besides the DNA code that makes it run smoothly. And if you'd asked people 30 years ago, well, what about the other codes? They would say there isn't any other code. There's just DNA. And then if you knew what was coming down the road, you can just kind of smile and say, boy, are you going to get shocked. Because the other codes, the methyl code, the histone code, the super enhancer code, the master transcription factor code, the microtubule code, and even the sugar code on the outside membrane, they all have high-tech, if you will, digital or computer-like, incredibly, beautifully organized information. And they're all in conversation with one another. You feel the shock? I thought DNA was shocking enough. And now you're telling me that there are other levels stacked one upon another, like a layer cake? Yes. Some people have said there are as many as 60 or more codes now that are coming to light inside the cell. It's like telling someone, you know, my computer is pretty impressive. It's got a hard drive, right? I just showed you the picture. This is actually from our desktop. Yeah, that wouldn't fit inside a slender laptop. But then what if someone said, you know, you're impressed with your hard drive, but did you know that every wire connection along the linear structure of the wire, there's codes that are actually etched in there that are important, that guard and guide the structure. And there are codes written in the outside, literally the plastic exterior. There are codes written into the beautiful, you know, like screen, the clear screen. Even though you can't see it, there are codes written into that. And in fact, every square or cubic nanometer of your laptop has embedded code. What would you say to that? Wow. You're kidding. You're making this up. No, that's a picture of our cell that's emerging from current research. So let's jump aboard the genome and epigenome and train and see what we can find. At the beginning, let me just say, I like the phrase informational macromolecules. Informational macromolecules. And I would encourage you to use that because I think it captures what DNA, RNA, and proteins all have. Would you help me, Don? Yeah. So we're going to go ahead. This is our protein. And as you know, proteins are made up of a string of amino acids, and they have the ability, if you've had a little bit of chemistry, high school or whatever, you know the proteins do not just get formed, they turn upon themselves. They kind of scrunch. They twist and in a very precise way form a three-dimensional structure, which could be like a bolt, a lever, an outside section of a machine. Usually the proteins do not get formed and just sit there by themselves. Usually, like 90% of the time, they're engaged in a team with other proteins. And those other proteins have to fit together just right, like a lock and key fit. Isn't that cool? And to think that the code of the exact order of the amino acids is really key for forming the protein. So let's just hold that up, but Don, let's get the RNA. Okay, hold it up a little bit higher, there you go. This is a representation of a copy of 1/2 of the DNA letter, and the RNA is actually what makes the code. And if you were to compare, let's hold them up together. For every 3 of these half rungs, we have 1 of these blobby amino acids. And another 3 half rungs, and then another amino acid. And actually, this pattern of amino acids is patterned precisely. The colors represent the different kinds of amino acids. We looked it up in our protein book. That was kind of fun. A little bit weird, but sort of fun. And so now, let's go ahead. Can we hold those together? And let's get and that RNA is formed from the master molecule, which is the DNA. So DNA, and we could twist this up, yeah. And why don't we just go ahead and put those 2 guys down? Very well done. And I'll let Don do the twisting. He's a great twister. Okay. I'll let him do the twist. Remember the twist? Kind of the 1960s crazy dance. Okay. Now, DNA actually is twisted much tighter than that. It's every 10 rungs is a complete 360. Isn't that amazing? That's how tight the DNA twist is. And it is an absolutely high-tech molecule because they've been playing with other, either outside, the white is the sugar. Sugar is white, so that's why we chose that for the deoxyribose sugars. And then what orange and blue, the gator colors, okay? That's, yeah, thank you. Are there any gators here? All right, go Gators. I don't know if they're doing that well, but we'll pray for them. Academically, yeah, okay. All right. Okay, so the T and, the A and the T are represented by the A, which is azul, if you know your Spanish, or azure is an American word used sometimes. And then the T is the tiger tangerine color. We had to think of it because A and T, and C and G, I don't know if you can see, we got a lot of these, like Christmas color with red and green, and that's crimson and green. Crimson starts with C, obviously green starts with G, so C and G. So A with T and C with G. And if you want to have fun, thank you so much. Wonderful, wonderful. If you like to have a little bit of fun, you can go see the video. It's a very short video. It's on DNA and Beyond. They're taking notes.org, not Bed Bath and Beyond. I think they're struggling a little bit. But DNA and, spell out the word and, DNAandBeyond.org. And if you go to that website, you'll see, first of all, there's a pop-up video. It's about 1 minute and 20 seconds. It's narrated, dive into the nucleus for DNA Day coming up in just under a month. And then if you go into our product, click on our product, and you can see a young man doing a demo of our own DNA model. And he actually has a song that goes with it. You want to hear the song? Yeah, I'm not much of a singer, but I'll try. I should really pull my, I'll just pull this out. All right, this is my attempt at operatic voice. Just kidding. Okay. A with T and C with G, held in place by D and P. P are the phosphates, okay, between the deoxyribose. When I rest, you will see methyl tags plugged into C's. Okay, let me pull them out. A methyl tag is actually plugged in to put this in a rest mode. Turns it off. Okay, methyl tags plugged into C's. Now I know my ATCGs. Won't you come and twist with me? Okay. Anyway, that's our attempt at teaching kids, teenagers, everybody the DNA. And then we have for RNA, we have a song for RNA. And believe it or not, the Lord gave us a song for the amino acids, all to the same tune. So, yeah. You can hear that or receive those at our DNA and Beyond website. So informational macromolecules. Macromolecules means long-string molecules like proteins, DNA and RNA. Informational means they're packed with information. And I knew a lady who really, I don't think she went to college, but she was sharp. She was a wonderful Christian. I was a witness for Christ. And I was giving a lecture, a very boring lecture on a Wednesday night prayer meeting at a church in South Carolina. And she was taking notes. And she was, everybody else was bobbing for apples. You ever had a talk where most of the people were falling asleep? That was the reaction I think I had that night. So I thought, boy, that was a total waste for everybody. Well, it wasn't total because a year later, she was in front of high school students. Her son, she had to pick her son up from high school for a doctor's appointment. And 2 other students were just ripping on creation and exalting Charles Darwin. And so she was just really kind of like, oh, I want to say something. And then she said, I think I took notes when Tom was in town. So she dug in her purse. She found her little notes. So she reviewed her notes. She slid down where she could see those 2 teenage boys. She said, have you heard about the informational macromolecules? And they said, what's that? She said, DNA, RNA, and proteins are all long-string molecules that carry very precise coded information, like a computer code. And they said, yeah, hey, we're studying that in our high school biology class. She said, yeah, I heard you talking about biology. Have you heard the puzzle, though? What's the puzzle? The puzzle is that scientists can't figure out any process in nature that would organize thousands, tens of thousands, and even millions of those letters in a precise sequence. So here we have a direct empirical evidence, well, what they like to call prima facie, or direct empirical evidence of an intelligent designer. And you know what those two high school boys said? Wow, that's cool. We didn't know that. And then she pulled out a little yellow tract called the Four Spiritual Laws. You ever heard of that? It's Campus Crusade. I think they've renamed it now. And she said, have you ever heard the Four Spiritual Laws? They said, no. It shows how you can have a personal relationship with that Creator. They said, really? And then she said, can I share it? They said, sure. And away she went. Now, what I love about that is that she built on literally, what, a 1 minute, maybe less than that, review of some notes she had taken a year earlier, and she turned it into an opportunity to build a bridge, an on-ramp, to those anti-creation students who just were mouthing, what they've been taught in class. So Mary Bergerson is my hero. She's now with the Lord, but she was a mighty, mighty, saint in my book. So that's kind of the launch, and now we're into some of the wonky, intelligent, we're going to say discoveries recently made about the genome, okay? And this is a sheet that I would encourage you to just kind of, as you have a chance, read it over. I'll refer to some of these items. This actually was provided by a pretty famous rising star author with Discovery Institute. He writes articles. He's actually written, I think, at least parts of 2 books, Eric Anderson, and he's a great guy. And so he sent this response to me as I was getting ready for my talk. So informational macromolecules is what we're talking about. DNA has a digital code. We've used that phrase before. And this digital code has information, as we said, in that 4-letter alphabet. Okay, A with T, C with G. And I could go on and on about how crafty and brilliant and bright and creative the solution was as God put that together. But just a reminder, 6.2 billion letters in each cell. And if we were to take one of these DNA models, we actually have available, if you want to pick up one tonight, a 3.5 foot, 38 inches model, and it has 21 rungs. We make one of these, it's actually 11 feet long. It's called the tRNA gene. If you know what a tRNA, we actually have the gene for that molecule. But anyway, our 21 rung model, if you put them stacked side by side on a football field, and you began making layer upon layer, do you know how many feet that stack would, as big as a football field, would amount to when you got to 6.2 billion? The stack would go up nearly 750 feet. It would be bigger, by over 150 feet than the Washington Monument, but much, wider. If you took all, that's from one human cell, using one of our model, as a kind of a basis. If you were to take all the 35 trillion cells in your body and try to duplicate with our model the volume of DNA, and if you could just fill up the oceans with concrete up to sea level, the DNA layer would rise to double the height of Mount Everest and cover the entire Earth. That's how much DNA you have in your body. That's really flabbergasting to me. So we can again say, as Psalm 139, we're fearfully and wonderfully made, and we only find now in the 21st century how true that is. They have added a new dimension, the genome. C stands for chromosome. The way that the chromosomes are folded in upon each other and they fit together, again, like a lock and key formation, that has added a new dimension separate from the code. And this enables adjacent chromosomes to have little conversations, little conferences with one another. Isn't that cool? Who'd have thunk it? Okay. Yeah, how are you doing over there? Chromosome 25? Yeah, I'm pretty good. How are you, chromosome 18? Yeah, isn't it convenient? But it's just by chance we're right next to each other since we engage in these dialogues that are so important for the function of cell. Yeah, it's amazing. It's like, I don't know how that happened. Well, the Creator made it happen. He designed the folding. Here's an example of one of the first discoveries in the yeast genome. And of course, the yeast genome has, I think, less than 10 chromosomes. But they found the precise folding was absolutely, completely necessary for the function in terms of where they are interacting with one another. Our model approach, as I said, has these the color codes trying to bring us together. But let me just point out that snuggled on top of those the C letters are the cute little methyl tags. And excuse me while I turn on my cell phone, which is blazing color here. It's off now. So one of the things that we find in this methyl tag mystery is that many genes have, it looks like a Mickey Mouse with an extra ear, okay? These carbon with 3 hydrogen tags that are placed on genes to just give them a rest, kind of, okay, you can take a nap. It's like your hotel. You have a do not disturb sign you can hang on the doors, right? If you want to take a little rest. This is like the do not disturb sign. And they are placed precisely right on the part of the genome where genes should rest so that the body doesn't use extra energy making copies of DNA it doesn't need. There are 35 to 55 million methyl tags in one genome. Think of that. And you would need this elaborate map, more complex than any map ever made by a human, just to monitor where those methyl tags are. But that's just getting started because each cell type, and there are over 225 cell types now, some people say 250, close to it. Each cell type has its own map of where the methyl on-off switches, the methyl tags are. You see the complexity? Because all the DNA is pretty much the same. This cell, this cell, this cell. Oh, yeah. You pick a cell, the DNA is always the same. But the switching system that sits on the back of the DNA is different depending on whether you're a brain cell, nerve cell, liver cell, bone cell, right, whatever cell. And when I began studying this, I thought, this is absolutely crazy. But it's part of the revelation, the shock of how beautiful God's creation is. Here we see the result. It's a microtubule highway. And as you see, it's both constructed and then pulled down when needed. And riding along, carrying a load on its back, is the kinesin molecule. You see that kinesin with 2 little floppy feet? And he pulls this huge load. This load are usually building materials for the outer part of the cell on its back. Is that pretty impressive? It's beautiful. Yes? Sure. I'll do the video thingy again. Okay. Yeah, and the microtubule is, by the way, is self-assembling because of the kinds of proteins, the block. Yeah, yeah. Mm-hmm. That is a very up-to-date artist's conception of if we could shrink ourselves down and zoom in, it would look very close to that. Okay. Discovery, I use this as, I've had this for like 12, 15 years. Discovery Institute produced a fantastic, it's about a 5-minute video. Have you guys seen that, the kinesin worker video? You've seen it, Art. It's great, isn't it? It's fantastic. And so I would recommend, but you'll see there's not much change. I mean, those heads, those floppy heads, they were, and matter of fact, they move, those heads, those little moving, what they call them feet, but sometimes, but they're like heads, move so fast. It's like, that's how fast they're moving. I actually acted this out in a seminar in Queensland, Australia, when we were there in 2007, and I had one of these big, blobby things on my back, and I acted out like it was a kinesin. And as we were breaking for like a brunch, had some, snacks and some breakfast food there. I looked out on the patio. My wife was finishing her dinosaur talk, and half of the guys out there were practicing their kinesin talk. That's what you call discipleship or cross-cultural evangelism. But it was, to me, when I saw the worker, you just go to YouTube and put in worker kinesin discovery for Discovery Institute. It'll take you right to it. And that'll be the 5-minute, like, up-to-date version. And actually, these guys will sometimes team up if they hit a blockade, if they're trying to get around a kind of a tough, scrunchy area. Another one will be brought over to help them pull the load. Isn't that amazing? So, and let's move on. Junk DNA. I had a guy that I met for breakfast up in Minneapolis, St. Paul, and he said, the only argument I know against intelligent design that has any weight to it anymore is junk DNA. So we just need to pray about that. And just, well, guess what? The U.S. government stepped in. So, I mean, people were praying. And the U.S. government, working with about, I don't know, 25 other countries, were organizing at 80 different labs across the world, starting in 2006. I think I said 2005. They were starting to investigate parts of the genome that didn't have known proteins. Like, they were looking at all the little pockets of like, you know, palm tree oases, but they were never looking in the so-called desert, where the DNA seemed to be just kind of junk and lifeless and nothing going on. Their theory was that 90%, 95% of the DNA was just leftover trash, junk from, you know, a billion years of evolution. Well, lo and behold, as they began drilling into what seemed to be kind of nothing going on here, they found that the copies were being made of the RNA, but they weren't going anywhere. They were staying in the genome, or near the genome, in the nucleus, and serving different functions. And they also studied to see if the actual code in these desert regions was changing, and it was absolutely rigidly staying the same. They're saying, that's weird. Mutation should change it. But if it's functional, if it's useful stuff, then it would need to change, not change. It would need to stay the same. So within literally the 2007 initial report, and then 2012, I think, was the final report, they concluded that instead of just 5% of the DNA is functional, 80% of your DNA is functional. Now, I call that an increase. What do you think? Hey, my fellow Darwinists, or I shouldn't say fellow Darwinists, my friend who's a Darwinist, you were telling me just 10 years ago that only 5% of my DNA is functional, 95% junk. And now these 80 laboratories across the world working together, just doing these kind of deep drilling in the genome, are finding that 80%. Now, what do you say about that? And he would probably say, well, I don't know. Our best people are working on that, you know. So I'll get back to you. And then he would check his atheist Darwin blogs. I mean, I just think it's like a tsunami of evidence that we're seeing develop. And I say break out your little tsunami writing, what do you call them, the skippers, the wave skippers, the wave jumpers. ENCODE, the ENCODE function that has been revealed is that there are up to 4 million in just one single chromosome, 4 million DNA dimmer switches involved. Now we're going to get into some of the items. This is going to be the most boring part of my talk, okay? So if you can just hang in there, I will hold your hand and we'll get through it. But I'm just going to tick off some and make a quick comment on some of these new discoveries that I think are pretty exciting, but, you know, like I say, it tends to maybe not be quite as amazing. The severe shocks that we're finding in the genome is that RNAs are exploding with function. Let's pull up RNA. Okay, this RNA that you see seems to be just a copy of the DNA which is sent out of the nucleus and then turned into a protein at the factory. But some of these RNAs loop back together. So if you'll take that in. No, you just loop it together. Perfect. And these looped RNAs can serve as like holders, springs, air traffic controllers, towers, scaffolding devices, and about 100 other functions. RNAs can also turn back on themselves like a protein does, but they have abilities that a protein doesn't have, and they're right there in the nucleus ready to be used. Isn't that amazing? I mean, to me, when I heard this, thank you. You can just keep your RNA there. When I heard the RNAs were exploding and their function was exploding, orphan genes, yeah, and we're going to move a little bit quicker here. The orphan genes are like where genes are discovered in the little twigs of the so-called evolutionary tree. So that a group of, let's say, salamanders that are very similar, they have maybe 3,000 genes that were just written for them. So we know for God so loved the world that he gave his only son, Christ, okay? Because for God so loved the salamanders that he wrote 1/3 of their library just for them. Oh, and by the way, he did that the same way for humans. Oh, by the way, he did that the same way for mockingbirds. Oh, by the way, and this shocks because they were just supposed to find like progressive, a little bit more DNA, but when you get to each individual kind, there's an explosion of DNA, which is not related to anything else, either further down the tree or with another kind. Because God created this huge, unique library just for that genus, or that family, but usually at the genus level. Okay. More shocks. Alternative genetic codes, so ATCG, but sometimes it changes. Very rarely, usually in archaea, what are called the rough life bacteria. Some bacteria enjoy living in boiling acids. Some bacteria enjoy living without any air. I don't know why they would do that. Some bacteria enjoy living in alkaline or acidic environments. Some bacteria enjoy living in freezing locations. These really weird, hardy bacteria that love harsh, locations and settings often will have different genetic codes. But they've been telling us the proof of Darwinism is that every known DNA system has just 4 letters. So now, what do you do with this new genetic code these weird bacteria have? Oh, I guess we'll have to stop using that argument for Darwinism. You see, the whole system is falling apart in explaining everything through just matter alone. Many pseudogenes. Now, a pseudogene is like a copy of a gene. I won't go into the details, but it's supposedly like a goofed up, messed up copy of the gene that is never used. And they said that until they found that many, it seems like most pseudogenes actually have function. That's a shock, especially if that was your other, besides junk DNA, this was the other number 1 proof for Darwin's theory. And I'll just close this series with bugs remain bugs. Professor, I believe he was at Michigan State, Lenski, was growing, I think, the equivalent of 1 million years of bug evolution. These are bacteria in his lab. And he thought that they were developing new functions, but Michael Behe, you've heard of him, irreducible complexity, showed that they're not doing anything new. And we're almost out of time. Let me just go ahead and just throw out a couple other things. That's really a complex slide, which basically says you can start and stop in different locations, and genes, to the shock of every biochemist, can sometimes start at one point, and then you move down 1 letter, and you can start a gene at the other one, and maybe even go in opposite directions with overlapping genes. That's just not supposed to happen statistically. And then the last thing I'll just mention very quickly, the newest revolution is DNA itself. As I said earlier, is being tested in terms of how it is operated, and there's something above DNA that operates it. So Time magazine, for example, said that's the quantity of information in DNA, and this is the quantity of information in the epigenome. Are you shocked? When I saw that diagram, I was shocked. Okay, well, what is this epigenome? Well, they call it the frontier, the hottest thing in biology, because that's the iceberg of all information. The genome is just the little tip of the iceberg. The epigenome, those other 5, 20, 30, 50, 60 codes are the under the water portion. We did our own conference on this, and we basically tried to show that they're able to do great strides in medicine because of this. And the strides in medicine include the discovery that the epigenome was responsible for this father, the grandfather, and the son having problems from epigenetic damage done in the 1800s. You see in the pink, the upper section of Sweden, Norrbotten, because of binging, eating during the heavy-duty big harvest, their epigenetic system that guided longevity was so damaged that the average lifespan dropped from 62 to 32 in just 2 generations. And there was nothing wrong with them organically, but when they began to investigate the methyl tagging of their on-off switches of the genes, that's where they said the problem was. So this has offered great progress in what we're learning. And so if we could have maybe Don give a 2-second testimony and then enter into a time of Q&A. I know I've touched on a lot of weird bases, but thank you for your patience.
Yeah, I don't think I need a microphone. Okay.
Yeah.
Oh, okay. I was just going to speak about a chemist named James Tour. So I just wanted to get a little information and know that it was solid. So I went on Wikipedia, of course. So James Tour was born in 1959. He's an American chemist and a nanotechnologist. He is a professor of chemistry, professor of material science, nanotechnology, and a professor of computer science at Rice University in Houston. His work primarily focused on carbon materials, chemistry, and nanotechnology. He has over 700 research publications and 130 patents. He developed different techniques of forming graphene, which is a single atom layer of carbon. And they use these carbon building blocks in order to deliver drugs for traumatic brain injuries. They build nanotubes, two-dimensional materials called rebar graphene. They can use this in concrete and make it 60% stronger with the same amount of concrete.
We got just 2 minutes. Okay.
Okay. So the graphene and the things he's been doing are just off the chart. But one of the most amazing things about him is not only being a scientist, is he loves Jesus Christ. And because of this, you know, in the scientific community, you don't do that. So he's known for coming out before a lecture, kneeling down and praying before the lectures. And his love for Jesus Christ is his main thing. But he's now studying mostly and doing most of his time. He teaches at Rice University, and he teaches a lesson every Sunday at the University Chapel. He has over 900 recorded lessons, and he just is an amazing person who loves the Lord, and he is a scientist of just great renown. Okay?
Thank you. Yeah. So we're basically going to say really quickly that James Tour is the most outstanding commentator on the origin of life issues, how the original DNA, RNA, and protein systems come about. And so I would say that if you want to just tune in to any of the many, and there's probably about 25 major YouTubes that have captured his teaching on the origin of life controversy, and he is very strong and very articulate and very powerful. So, and I'm going to just turn this little guy off. Thank you. So we're going to go ahead and say we're good with that. We are ready to take Q&A at this point. Okay, we'll just, okay? Sure. Yep. Okay. James Tour.
T-O-U-R.
T-O-U-R, yeah. Yeah, James Tour, yes. Yeah.
And by the way, James Dr. Tour was raised in a Jewish household and came to know and love Jesus Christ through his science and discovery and seeking the truth, which is interesting. Did you have a question?
Yes, sir. How do you deal with people in the world of science that are, like the Bible says in 2 Peter chapter 3, willingly ignorant? There's just like the carbon dioxide, this whole carbon dioxide. You know, it's 300 parts per million. And if you measure it on an evening in the middle of summer, it's like, 20 parts per million. And they're saying there's too much of it. And it's so obvious that there's wrong, that there isn't too much. So, I mean, how do you deal with the outrageous, willingly ignorance?
Okay, well, I mean, I'm not up on that particular issue. So I'm not going to, I love the question. So I'm going to answer the question coming at from a slightly different angle. Is that okay? Okay. So I'm going to propose as a model that we quote Gamaliel. You remember Gamaliel? He was the Jewish theologian. Paul studied under Gamaliel. He pops up in Acts chapter 5, basically saves the day to some extent for the disciples, as the Jewish leadership is ready to just kill them. I mean, execute them. And Gamaliel stands up. And he's not one of us. He's not a Christian. He's not a Christ follower. He says, be careful what you're doing. And he tells about two other claimants to some kind of messianic fame and role in their history. And they were killed, and their group dispersed. And this guy came up. He was done away with. His crowd, went away. Nothing happened. He says, if this Jesus really is somebody who God is working through, you don't want to be found fighting God. Okay, so I caution you, stop your, the hatred, which is boiling over like a volcano. I'm putting my own words in here. And get control of yourself. And they said, oh, okay. So they just kind of beat him up a little bit and sent him away. Said, don't speak the name anymore. Of course, they didn't follow that. They were following God. But I like to think of Gamaliel as the model for at least 25 major figures God has raised up since 1950, mostly since 1965 or 70, all of whom were either agnostic or secular Jewish or atheist, and all of whom either specifically said they think there's evidence for Jesus' resurrection, or at least supported the critique of Darwin and said there is something to this design. I have recorded. If you're interested, just sign up. I'm going to put a sheet in the back. Just sign here. So Don, if you could just help me do that sheet. So when we get back there is a pen. Oh, you got a pen? Okay. So just say sign here for Gamaliel. I will shoot you gladly through email. It'd be preferable. It's about a 4 or 5 page summary, and each one has about a paragraph or two on each of these figures. Okay, for example, Thomas Nagel. Some of you may have heard of him. He is a famous philosopher, atheist to the core, still an atheist, but he has attacked Darwinism and specifically brought in the DNA issue vociferously in his Oxford University book called Mind and Cosmos. I read that book. I was so struck with it, I wrote a review. And I'll include my review of his book along with the Gamaliel article. So I think that when you're dealing with people who are like that strong and almost like asserting things that are demonstrably false, I'm right now dealing with a member of my family who's an atheist and a Princeton grad. And so I'm like, and I realize if I would just try and just say, what are we to think if this atheist has already gone public and said this? What are we to think if that agnostic, world-renowned expert has gone public? And I think that may help. At least it'll maybe calm. It'll get them to maybe do the bunny path to that link we send them to and actually listen or read. So that's one idea I have. So let's maybe discuss later. Okay, I have a question. Okay. For recording purposes, thank you so much.
All right, a lot of the world leaders today are listening to some atheists about genes and DNA modification. We all know Hillary, who is proud to be an atheist, announces God. He's talking about manipulating our DNA. I want your opinion on what you think mankind is capable of doing to our DNA, to the level of all these, to the epigenome that you're approaching, right? How thorough is that, and what do you think man's capabilities are?
Well, thank you for such a simple question.
Sorry.
Oh.
Current event.
Yeah, current event. This is the intellectual cowboy church, right? And the very, very advanced reasons to believe truth. Okay, so I think, C.S. Lewis, I think you may be aware, wrote a book called That Hideous Strength, which literally is about, I think today, I mean, he just saw what was happening at his time, and he projected 40, 50 years. So what we see happening today is reminiscent of the scary stuff in that book, That Hideous Strength, where the scientists try to take over. They're trying to follow the science, only they're making it to an extreme. I mean, forget about normal ethics and morality. We create morality based on our super intellect. Well, that sounds Nietzsche, God is dead, and we are just got to step in and do the best we can as we replace him. So what I would say is that the demonstrated problems that we've seen already, I mean, super difficult and backfiring problems with trying to meddle with genetic engineering is one indicator that we can just bring to people's attention. And I would say my favorite website to go is evolutionnews.org, the Discovery website. And I know reasons.org has a great website. But for daily flow of information and great, Discovery Institute does a great job in monitoring all these areas, including the genetic manipulation area. Secondly, I think that as you look into the pattern of what's been already happening, a lot of people that were like 10 years ago advocating for genetic control and modifications are backpedaling now. And I think if you can just keep up with that, I mean, that's my first stab of an answer. That's one of the more really interesting and challenging questions. Yes, Art. Okay, so he's going to arrive very quickly. Thank you, Gary.
To add to that reference to James Tour, a lot of the biochemists around the world dislike James Tour, and the reason they do is because he calls them all liars. And he's very blunt about it.
He is forceful and
they're
blunt.
lying because none of them can create a cell and can't even start to create a cell. And that's what they're, I mean, really,
Yeah.
he's really bad about it. He's not really nice about it. He just outright calls them liars.
Yeah. Well, and so the question is, do I agree with that or?
Trying to change the cell around, it's not an easy matter. A lot of people say they can do it, can't.
Well, I was just listening to James Tour today on one of my feeds. It was from a lecture and interaction he had at Rice University, of all places. So the club, the Apologetics Club, Ratio Christi, invited him to come. And I think it's a little over an hour long. I think you've seen that one. And it's only been out for, I don't know, maybe a year, and it has, I don't know, 25, maybe it's 600,000 hits. It was enormous. It's like 2/3 people watch this. But he is very forceful. Now, he may have used the word liar. I didn't remember. Okay, he uses. Okay. So, what I would say is he's passionate. I mean, so he sometimes almost spits out his words, and I feel like when he's critiquing people who are not honest about what they have been doing, they've been sneaking in purified agents, when in nature you would never have chemically pure agents to play with and to monkey around with. And so I appreciate his fervor and his passion, and I was even debating, should I link this to the person I'm trying to, talk with, right now. And all I can say is I think that there may be something to be gained by including at least one or two of those Gamaliels, those secular atheists or agnostic, or some of them are Jewish. And if I send this to you, I think you'll be shocked. I mean, that'll be my subsequent shock on top of the DNA shocks. I just am excited what God has raised up. It's amazing. Okay, and we have a question here. And so, thank you. Oh, okay, so we'll just wait till the microphone arrives for the recording purposes. Thank you.
This is all new to me, okay, but I was curious that they're cloning animals, and do they have to use DNA to do that?
Oh, to clone them?
Clone them.
Oh, absolutely. To clone an animal, And they have developed the ability, they don't have to take any of the germ cells, like the egg or sperm. They can just use like, you know, a skin cell and basically tell the skin cell, okay, you're no longer a skin cell, you're now a germ cell. And the skin cell says, okay. And I don't know how they do that exactly, but I know that they've advanced the technique to that place. The problem is once you clone that animal from the skin cell, yeah, you have the library, but you have the unique epigenetic systems of the skin cell, not the original cell that launches the whole creature. Okay, so again, I had one slide I didn't have a chance to show, but it's fine. The whole Darwin theory is not only based on matter only, you know, no intelligence allowed. You may have heard of the film, Expelled, No Intelligence Allowed. I love that film. The idea of Darwin is so gene-focused that when you bring in these 5 or 30 or 60 other parts of the cell that have code, different code, and they're having conversations with the DNA code, how does Darwinism explain that? And the answer is, our best people are working on it, right? Give us a little bit more funding, please. You know, we'll get that the answer. Probably 5 years. We can do it in 5 years. The answer is they're not coming up with anything at this point, and I don't think they ever will, because they realize it's a lost cause. But of course, they got to keep. They can't backpedal. Okay. So and go ahead.
So there's no such thing as a true clone.
That's an interesting question. In other words, a true clone would be an absolute duplicate of the person, almost starting from scratch again, which then would, I think there's something, as far as I can tell, depending on how you define the words you're using, I think that's true. You could almost say that the clone is a wannabe clone. It's a pseudo clone. It's a kind of a loser clone. I don't know. And so that's where I think your question has great merit, and that's my stab at that answer.
I'm so sorry, but would that correlate with like identical twins in utero?
Identical twins in utero are true, so let me just say, as opposed to identical twins, which are true clones, in the best sense of that. In other words, they have identical DNA, but epigenetic patterns, the off and on switching, depending on their lifestyle, it develops differently. So I know quite a few, identical twins. I actually had identical triplets that were in the school next to me that we grew up with. And it was shocking, just to look at it. They're all the same. They look identical. But of course, their lifestyle then through the epigenetic, the other switching systems, the on-off, the methyl tag, and like those other many systems, all the way out to the outside rim, to the membrane. Those systems basically made them not evolve, but changed differently. So they look differently in adults. But they started identical, as opposed to the clone, in which they're really not starting identical because they're taking a skin cell and fooling it.
Can you speak about the discoveries and the fine-tuning and how the finish line for them is moving away rather than...
Okay, can I speak to the new developments in fine-tuning, like of the universe?
Of all the discoveries, like on Darwinism and all
Okay.
evolution, that their goal line is moving away from them because of the information we're finding to find the complexity.
Yeah. The only way, and this is where I would say one of the most powerful, how should I put it? One of the most powerful lines of discussion or argument, and there's a line of evidence that we can share with somebody today, is that we have proven in a laboratory that if you need only one mutation, you can make a progress. If you need 2 mutations, it's going to take probably millions or billions of years. If it requires 3 coordinated mutations, forget about it. I like the phrase, forget about it. Isn't that a great phrase? It will never happen. And we know this not just because a lot of smart people have thought about it, but Michael Behe wrote a whole book on it. And that was his second book, The Edge of Evolution. If you've never read it, you have a treat. It may be a little bit tricky, maybe a little bit hard at places, but it was written for the general public. So The Edge of Evolution, Behe has shown that if you try, and this is part of the fine-tuning, I'm trying to bring it back to fine-tuning. If you look at the way each gene is written, it requires usually 300 to 3,000, sometimes 30,000 letters lined up just right. That's like pouring out alphabet soup, or this pasta that's used in alphabet soup, from the top of the Empire State Building, maybe like a ton of it, and say, oh, it's going to form the Constitution when it hits the pavement. I'm sorry, that will never happen even if you tried it in every planet of the universe and you let that happen twice an hour for the next 6 trillion years. It'll never happen. It's provable. It just will not happen. Why? Too much specified complexity. Okay. So if you look at just the blockade, if it's one, it can happen fairly quickly. It may take years or decades. 2, it'll take millions of years. 3, that's the stoppage. But once they discover that principle, as far as I'm concerned, in 2007, Darwinian theory was ready for the casket, right there. And people are just resistant to the freight train of truth that's coming right at them. Because they don't want to get fired, they don't want to get demoted, they don't want their research projects to be canceled because of guess who runs the ship. But if you read the famous book, the most important book of the 20th century is Thomas Kuhn's book, The Structure of Scientific Revolutions. He says as you progress and people retire and they die, a paradigm will shift. Except this is the biggest paradigm shift of all time, and it just takes a little longer. And maybe Jesus will come back before the paradigm shift happens, but who knows? And I think we're seeing right now, and I'll just close with this, and I'll turn it back over to you. Okay, in The Guardian, Stephen Baragni, have you ever heard of him? Write down the name. I can include it in my little sending if you just say, articles, Gamaliel's and articles. Stephen Baragni wrote a powerful piece just last summer. I think it was June or July. And Guardian is a left-wing newspaper in England, right? The title, this is in a left-wing newspaper, Do We Need a New Theory of Evolution? Now, he's not entertaining intelligent design. Okay, got it. That would never happen, okay, in any left-wing newspaper. But guess what? The people on the outside who are taking pot shots at the Darwinian mechanism say, hey, Darwinian mechanism was proved wrong decades ago. How can you keep clinging to it and teaching young people that it worked when we know by every indicator it's not working? Well, no, really, I think we're making progress. No, you're not. And the whole article was like reporting this within evolutionary thought, this civil war. I think every student in the world should read Stephen Baragni's summary article. I'll send it to you, okay? It's a little long. It's like, I don't know, 10, 12 pages. No longer than 15, I don't think. But you'll see the almost invective, the bulging veins in the neck. Like, how can you say that? Well, it's true. No, it's not true. Yes, it is true. We've proven it. Back and forth, back and forth. And I think we live in exciting times. The paradigm shift is underway. It's just, again, it's a huge, vast paradigm. It takes almost forever, seemingly, to let it happen. So, back to you, Gary.
Thank you very much, Dr. Woodward.
Thank you.
Folks, this has been great. Let's give him a big hand.
Thank you.
Thank you so much for coming up and visiting with us. Thank you, Stable Faith Cowboy Church, for these great questions. Fantastic. In the questions that were asked about cloning and being able to recreate DNA, I'm reminded of the story. That someday in the not too distant future, the scientists have figured out how to create a living human being from just the dust of the earth. And so they challenge God and they say, God, we don't need you anymore. God says, oh, really? Well, let's have a little contest and let's see who wins. And so the scientists say, okay, well, the first thing we do is we gather up our dust. And God says, that's my dust. Make your own.
Yeah.
And of course, we all know from previous discussions that dust is made in the fuel of in the energy of the stars, right? When they go supernova, all the heavy elements come out of the stars. So good luck with that. All right, so we have a couple of action items for tonight, I think. One was put your name on the list so that you can have Dr. Woodward send you the information that you promised. What, Ellen, would you start a piece of paper back there? You got it? Oh, okay, Don's got it. Thank you, Don. And let's see, number 2, you have these sheets that we passed out earlier. Take a look at those at your leisure. And also, the third thing that I heard was pay a little bit of attention to Dr. James Torr and some of his videos. I've watched maybe 5 or 6 of them, and he's fascinating. So once again, give it up for Dr. Woodward, his assistant Dawn, coming down to visit with us.
Thank you. And let me just say that that strange creature in the back that looks like an alien that crawled off a flying saucer, that is a single histone. It's a model we produced for one of our epigenetic conferences. And that's the way DNA is stored. It's wound around twice a spool. And then it goes around another spool and another spool. 30 million of those spools in one cell. So that's how the DNA is organized. And those little tails sticking out, all I can say is go to dnaandbeyond.org and you'll see what happens to those tails, okay?
Wonderful.
Thank you.
Thank you very much, sir.
Yeah, thank you.
All right. Good night, everybody. Next month, we'll have Vince Rocca with us, coming from the Tampa chapter of Reasons to Believe. You don't want to miss it. I'll have details coming up in the bulletin.
Okay, thank you.